Right. I think we'll go ahead and get started. I want to thank everyone for joining us today. Today's webcast is about Autodesk Forge. We're going to give a basic platform intro, talk about some of the key components and a little bit of the history of Forge. And then after that, we'll dive in and take a demo of how you get started. And if you want to learn more about Forge, you can join us on our next webcast. If you're registered for this one today, we'll be sending an email with a sign-up link for the next one, where we'll go a lot more in depth with the Forge viewer, what you can do with it. And then of course, we'll take a look at a demo we've built and show you around the platform. But without further ado, first I want to talk about our company, Laudersoft. So we're a software development firm based here in Montevideo in Uruguay. Right now, we have 10 developers that are living and working kind of worldwide. So most of us are in Uruguay, but we have other employees in Argentina and Spain. Our company is about 3 years old. We were established in 2019. And since then, we've grown to take projects on 3 continents with, like I said, consultants working in all 3. Each year, we've doubled the company in size. So if you join one of these events later this year or early next year, you'll probably see these numbers change a little bit. But first, you're possibly wondering what we do. We're a software consulting firm, which means that our team builds software. But more than that, we're able to consult on the best ways to build tools, whether that's integrating between platforms. Maybe it's as easy as building a simple automation or add-in for other tools you use. We can help you anywhere from designing a brand new platform all the way to upgrading and maintaining tools that you already own. You're possibly curious about some of the tech stack we use, and I want to highlight one of the little differences about our company. So some of these, such as Java, Tableau, TypeScript, pretty typical tools. I think what makes our organization a little bit different is you'll notice that there are some Autodesk tools listed there. So BIM 360, Revit, and of course, we're going to talk about Forge today. And that's because our company's key focus is on helping companies that work in the AEC industry or for other organizations that own and manage space. So we work with lots of engineers, architects, people who own space like co-working companies or office space companies. And without further ado, I want to introduce your presenter today. Jaime, would you mind introducing yourself? You may be muted, by the way. Try it now.
Right. Thanks, Mike, and thanks everyone for joining us. We plan to give you a 2-part class today. During the first part of this session, we are going to talk about the history and background of Forge, where the product came from, what it's commonly used for, and also an overview of all its components. After that, we will dive in with how to get started, and I will show you the first step you will need to take when creating a new application. But first, I will tell you a bit about myself. My name is Jaime Perno. I'm 33 years old. I like nature, animals, and traveling. I love chocolate and mint, and my favorite musician is Buckethead. In my opinion, he's the best guitarist ever. So let's start. Before we really dive into the Forge platform, there is one key concept that is essential to understand: APIs. API stands for Application Programming Interface. That means that an application that has an API will allow you to expose the data from that application and use it elsewhere. In other words, it's a way to communicate applications with each other. If you want to think of a real-world example, think about getting money out of the bank. There are a lot of ways you can do this. You can go in, speak to a person, ask for withdraw money. Going the traditional route here means that you need to go during normal operating hours, wait in line, talk to a person, etc. Alternatively, at any hour, you can go to an ATM, verify you are able to take money out from the bank, and directly pull it from the machine. Often ATMs are accessible far from the bank, even overseas. APIs are kind of like that. They allow you to pull data from one system to another by having an open window to your data. I'm oversimplifying the concept here a lot, but the big takeaway is that you can almost always access your data in many ways. If you want to check how many windows of certain type you have in a project, you can simply open up Revit and count them, but maybe the person counting windows doesn't have or know how to use Revit. What happens if the person mistakenly miscount the windows and order the wrong Windows number, right? This is where APIs come in very handy, and you will see that they are a key component of the Forge ecosystem.
Thanks, Jaime. So we're not going to talk much about the history of Forge, but to understand the whole history of the platform, you need to understand a bit of the history of making things and some of the data shift that's happening all around you. If we think back to the beginning of time, you might imagine people making rudimentary tools, shelters, and buildings. Hammers, the shelters I mentioned, everything was crafted one-off by hand for thousands of years. And I'll note that I don't think the lack of a drawing really ever stopped someone a few thousand years back from breaking some flint or creating a structure over their head. Over time, we invented the concept of standardization and interchangeable parts. That's why if you go to the mechanic and get the oil changed in your car, the mechanic probably has an oil filter and a standardized wrench to pull the drain plug. To get to standardization, you really need to standardize how you're building things. And for centuries, that's meant scale drawings. In the last century, we figured out how to draw quicker with computers and even manipulate those drawings. The end point of the drawing, however, has always been to make an object, whether it's a building, a car, a component, or anything you're producing. You draw the object and then you produce it. Today, however, that's really changed in many industries. Design data can be used for so much more, from optimizing the number of desks that fit in a certain building to tracing your materials through the supply chain. The ability to interweave design and engineering data is really unlocking new efficiencies for businesses around the world. So our story really starts here in late 2015. Autodesk announced the Forge platform, which was a new kit consisting of APIs and software development kits. This platform would allow developers to natively leverage data from design and engineering phases in other applications that they built. Along with the announcement of the new platform, Autodesk also committed a $100 million fund to assist companies that were getting started in this space. So you know that Autodesk is committed to the platform. And in the last 6 years, they've continued to add more features and functionality. So in the last couple of years, they've added the TokenFlex API, and you'll see that they continue to invest in the platform so that it's got a robust future. So what is Forge? Well, as we've already mentioned, Forge is APIs, specifically 9 of them. We're going to talk today about each one in depth in a few minutes. In general, you can use one, many, or all of the APIs when you're pulling data into your applications. One of the great things about Forge is that Autodesk heavily supports the ecosystem. At the end of this session, we'll suggest some other resources beyond this presentation that you can use to learn more if you're just getting started. And of course, shameless plug for our next webcast, join that one to learn more about the Forge viewer specifically. Beyond simply learning how to use Forge though, you can take a look at the vast ecosystem that's been created with it. There's numerous systems integrators out there that can help you build with the platform or integrate with other applications or workflows you're already using. Of course, I'll give a shameless plug for our services. This is something our team can help yours with as well. So where are we going to start? As we dive deeper into each component, I don't really plan to go in any specific order, but we did prioritize some of the most commonly used ones. Dependent on your user needs, you may choose to utilize some or all of the Forge platform APIs. Remember, Forge is extremely broad, so you likely won't need to utilize each of these components for every application. But we're going to start with one of the most commonly used components here, webhooks. Webhooks, if you're unfamiliar with them, allow your application to receive and process alerts or notifications in real time. They differ from APIs in the fact that they're always ready to receive information, whereas an API either runs at an interval or when you make a scheduled call. For example, a user may want to know when a file has been updated or other changes have been made without opening up a design application. If you've ever tried to order concert tickets, you may be familiar with the concept of hitting refresh every 10 to 30 seconds. As you're aware, this isn't really an efficient use of time at work. So instead, if you need to know the moment something has happened, a webhook is your best bet. Webhooks are commonly used in a variety of situations. At Loggersoft, for instance, we use Slack for internal communication. Several of our channels utilize webhooks for alerts. So for instance, our daily stand-up meeting, when this meeting is about to occur, it sends an alert through Slack to all of our team members. This ensures that your users get an alert when they need it and that they don't need to pay close attention to a clock. Oops. Next up, we're going to cover the model derivative API. So the model derivative API allows data about your projects to be shared with outside stakeholders and other programs. Most data consumers, as Jaime mentioned, don't actually need full access to a native model or drawing file. They simply need to know what specific object or building a drawing or model is referencing. And one thing I want to bring up is we've probably all worked on large projects where file names are descriptive, but only if you understand how to translate them. For example, a building or a component may be labeled with a long string describing it, where it's located, when the project started. There's all sorts of data that you embed in these ways of naming files. If you're unfamiliar, however, with how to decode this meaning, or you misread it, you may end up referencing the wrong data once you get it open. Instead, it could be a lot simpler if you just want to look at the thumbnail of the object in question. Maybe you even need to pull geometry or open another file in an application. The model derivative API makes all of these tasks simple. You can use it to generate thumbnails, translate files to another format, extract data about your model, or pull information on the geometry. We're going to discuss more about the model derivative API, but one thing I want to mention is that this is a key building block for a lot of the other Forge applications. Next up, we're going to talk about the Forge viewer, and the viewer is exactly like it sounds. Specifically, it's a customizable zero-client WebGL interactive 2D and 3D viewer that doesn't require the end data consumer to have a software tool like Revit or AutoCAD installed in order to view a model or a drawing. One thing I want to note is in order to leverage the viewer, you must use the model derivative API. So like I said on the previous slide, the model derivative API is one of the key building blocks here. The Forge viewer has many applications. You can embed models or designs into your web page or platform, and they keep updating according to your version. You can use them to share what a space will look like with other stakeholders who may not have access to Revit. For instance, if you're an architecture firm and you want to show your client what your design will look like and let them play around with it, the Forge viewer may be what you want to use. In short, if someone needs to visually review a drawing or model but doesn't need access to the software used to create it, the viewer API is used to create these platforms in question. Next up, the data visualization API. And I think this one is always a hot topic. Whatever you're doing with your data, being able to visualize it, slice and dice, and gain insights by looking at it instead of reading has been popular in pretty much every industry, every group at work, even fantasy football. You see a lot of people who are doing very well there using data and business intelligence tools to slice and dice their data. The data visualization API in Forge goes simply beyond allowing you to pull your design data and use a platform like Tableau or Power BI on top of it. It actually allows you to pull data from other sources into your model and visualize it on top. The data visualization also requires the Forge viewer. So when you're setting up your project, you'll need to check the options for the model derivative as well as the data management API. But we'll talk about that a little bit later. But first, I want to mention some cool things you can do with the data visualization API. For instance, many organizations are attempting to limit energy consumption or have other IoT devices embedded in their facility. You can use the data visualization API to overlay sprites in your models to represent sensors and icons. You can also add a timeline user interface and other components into your application in order to tell stories that you need to with your data. One of the cool features is a surface shading capability. This will allow you to use your model to display heat maps, and you can show other data such as airflow, temperature mapping, access to Wi-Fi, and more. The big takeaway here is if you need to superimpose data on top of a model, the data visualization API is going to be your friend. A lot less sexy than webhooks. The model derivative, excuse me, a lot less sexy than webhooks, model derivatives, or the viewer is your data management API. But I think it's a lot more important. This API gives you a structured way to access data across BIM 360, A360, Fusion, and the object storage service. Remember that BIM 360 has quite a few components like docs, glue, teams, and layouts. If you need to manipulate data in any of these via an outside application or interface, the data management API is what you'll need to use. One thing I want to point out is that the API is a bit limited here. This isn't a case of if you can dream it, you can build it. Instead, like many other APIs, if you're using the data management API, you're probably using one of the others, such as the BIM 360 API. And on that note, the BIM 360 API. I only have 2 minutes per slide here, so I know I'm really not doing this API a lot of justice with this limited time. This API consists of quite a few things, so we're only going to highlight the most important applications here. If you have questions, however, you can ping me or Jaime offline or attend our future session on BIM 360 and Forge. First, the BIM 360 account admin API can automate the setup of projects, assign admin staff, or even other project members, and can synchronize data with your external systems. This can be incredibly useful if you work in a large organization for tasks such as user management by integrating with other tools like your people management software. The BIM 360 Assets API creates and manages assets in the, creates and manages assets in the BIM 360 Assets service. You can use it to control custom attributes, categories, status, and more. One of the most useful features is the search functionality, which allows a search based on any of the above. The BIM 360 Model Coordination API is useful when combining models that have lots of different disciplines involved. Once the models are combined, it can help a user detect any issues that may have arisen during this process. The BIM 360 Document Management API helps access, upload, and store models or drawings so that stakeholders can collaborate on the same project. And the Locations API does just like it sounds. It allows you to manage hierarchy and locations of your drawings and facilities. There's also a few other APIs in beta right now that I want to mention, but they may not be completely ready to be used in the industry yet. There's a BIM 360 RFIs API, and that creates, tracks, and updates your RFIs, as well as a cost management API, which provides access to data stored in the cost management module. Next up is my personal favorite, the Design Automation API. And I'll start by asking if you've ever performed the same task over and over again in real life. Maybe a task like data entry or manipulation in a spreadsheet, or it could be something like looking through your photos and editing or discarding the ones that you don't want after a family vacation. As you sift through data, or your photos in this case, you probably create rules in your head. In my example, is the photo blurry? If so, you discard it. If not, maybe it needs to be cropped slightly, and then you change the brightness, tweak the colors, do whatever you kind of need to do for the look and feel you're getting. Once you get into the groove of it, this can be really simple but mindless work until you accidentally delete something and then pay more attention to what you're doing. In general, if you can write a set of rules for what you're doing, you can probably automate it. In this case, you can automate changes with the Design Automation API. Maybe you're working on a project where stakeholders need title blocks in different languages, and I'd ask you the question, should you manually go in and translate each one of them and then save your drawing again? That'd be really, really tedious and time consuming. And tedious and time consuming tasks lead to complacency, which in turn leads to errors. The Design Automation API is one of the most flexible APIs and allows you to do many things. Some examples include checking files for issues, then presenting a list of items that didn't pass, importing and exporting parameters to spreadsheets, upgrading files to a newer format or release, converting inventor files to Revit, or changing the height and width of an element. Autodesk's website has a lot more examples, and you can search GitHub for a variety of tools that you can use yourself without reinventing the wheel. Next up, we have the Reality Capture API. And While there's a lot of greenfield projects in the world, I find today it's far more common for spaces to be reused. Maybe you're an auto manufacturer that buys a facility from another manufacturer, or even an office space company. They often buy a building, update, renovate it, and then turn around and put offices back out on the market. We spoke earlier about how design data is used after construction or creation, or, well, sometimes the lack of use. It's not uncommon for drawings to go in someone's file cabinet or binder and rarely be accessed. I know when I was working in oil and gas, selling analyzers and integrated equipment, this was a common problem. I'd go sit down in someone's office, we'd start talking about a project, they'd need to pull a PNID or a CAD file, and usually what they would do is go to a binder or even sometimes a file cabinet. Often what I found is that the drawing didn't really match what was in the field today. Slight updates had been made, and no one had updated the documentation after the fact. Today, you may even have digital copies of the files, but your end result's the same, is that drawings sometimes get created and never used again. Those renovations may have occurred, and your documentation just isn't that great. If you're working in an industry involved in renovation or reuse of space, you're probably familiar with a lot of the commercial reality capture tech on the market today. Laser scanning seems to get cheaper and cheaper every single year. The reality capture API can help you with some of these types of applications. It allows you to convert geotagged photos, such as those you take from a drone or a camera, and it converts them to textured meshes, dense point clouds, and orthophotos. It also allows you to run more than one job at once, so you can use all sorts of input, like I mentioned, your drone or your camera, but you could even use your phone camera. Your data output will include either meshes, point clouds, orthophotos, but it'll also give you quality reports. Last, we're going to talk about the TokenFlex API. Often this is the most underappreciated API in the full set of tools. And really what it does is measure application usage. This is really useful for larger organizations, and it's really limited to those on Autodesk Enterprise account plans. So if you want to monitor consumption, you'd be using the TokenFlex API. So in recap, Forge is APIs, 9 of them specifically listed here, and use them to manage and manipulate data in the Autodesk ecosystem. So we'll get started. Jaime, you're up.
Okay, so you probably already have some idea about what Autodesk Forge is. Maybe you are aware that it's an automation or software development platform of some kind. Maybe you know a little bit more about it or some of the applications. In general, it's best to think of Forge as a common cloud-based platform that allows you to integrate your design and engineering data with other applications via the cloud. You have probably heard about lots of appealing new technologies such as digital twins or integrated factory models, like performance dashboards or senior prop tech company website where you can see and interact with a live model of an office space or an apartment unit. A lot of these applications are built using Forge. Okay, we have gone through the background and basics to what Forge is. With the rest of the time, I'm going to walk you through how you get started with Forge. First, I will give you an overview of the process for starting using Forge services. Then I will show you a working prototype we have built for one of our customers. If you miss a step, don't worry, we are recording this session and it will be available online next week on our website. If you already have an Autodesk account, you can skip this step. I added here just in case, because you do have to register in order to start using Forge. Once you have registered, you will receive a validation email. Note that you can also sign up for a trial account to try out the tools without paying. After that, you have to log into Forge by using your Autodesk credential we have just mentioned in the previous slide, and then create a new Forge application. By default, I usually select all the API services here, just in case, because I mean, if you already know your needs, you can simply select them accordingly. Next, you will come to a screen like this. There you will find the client ID and client secrets for the created application. You will notice that I have blurred some values here on the slide for security reasons. These are keys that you want to have on hand, similar to your booking code for a flight. This is information that should not be published for security reasons. Under the Custom Integrations tab, you should select All Custom Integration. Then you will see checkboxes for BIM 360 account administration and document management. You want to check both of these and then select I'm a developer. At the end of this process, you will get the BIM 360 account ID. Same as the client ID and secret, you will use this value later because these three values are required parameters in most of the API services. Okay, let's move and see our work in progress prototype we have built for one of our customers. We are going to play back a video and I will explain you some important things. Okay, first of all, I would like to mention that documentation is important here, and Autodesk has made an awesome job with the Forge documentation. It is well explained, super clear, and easy to follow. If you are wondering, for example, how can I get my BIM 360 projects information? Well, the only thing you need to do is to go here to the BIM 360 API reference. There you go. Then select Account Administration, Projects, and Get Projects. Here you have all you need in order to pull all the project's information. Everything is here, the endpoint URL, the required parameters, and also at the bottom you will find a request sample with its response. So yeah, documentation is there for helping you. Just give it a try. Another thing I want to mention before moving to our prototype is that we have already created some entities into our Autodesk account in order to save some time, such as projects, files, users, and members. So here we have some projects, in this case, project 1, 2, and 3, right? We also added some files into those projects. In this case, we added these 6 files into project 1. Here we have some Autodesk users. And finally, we define some members for the projects. In this case, project 1 has these 2 members. Having said that, let's move on and let me show you our prototype. This prototype has 2 main features. The first one is to allow the user to easily navigate through all its projects and their files, and also provide a preview of them. So on the left, there you go. On the left, you can see all the available projects we have. Let's select project 1 in this case. Now on the center of the screen, you can see all the files included into that project. Remember that I told you that we have already added 6 files into project 1. By the way, all this information is being pulled by using the Forge APIs, right? Let's select one file here, for example, this Revit model. There you go. Now we have this awesome file preview. This is the Forge viewer component that Mike already mentioned earlier. This is just out of the box UI, but of course you can add some extra options here and add some cool stuff according to your needs. This is just great. So, okay, the other key feature we also included is the project member management. Once again, let's select project 1 here on the left. As you can see now, this project has 2 members. Let's add an extra one and save the operation. Okay, now if I go back to Autodesk here and I refresh the page, you will notice that a new member was successfully added. So that's it. That's our prototype. It's more like a proof of concept right now, but it works, and doing so allowed us to try Forge, and it was a really straightforward experience.
Thanks, Jaime. So we're getting to the end here. We like to keep these short because we know you want to eat lunch too. Keep in mind Forge is a collection of APIs and SDKs you can use to leverage to build applications. There's a few limitations to this system. So for instance, you're not going to find an API for every BIM 360 application. And you'll need to use some services by default, even if you don't think you'll need them. For instance, the viewer is always going to require the data management API. And then if you're using other tools on top of it, you'll need to select those as well. There's also a large Forge community to learn from, and you can ask questions online. There's subreddits about it, obviously different user communities in person, and you can attend these and meet other people in your industry that are building with Forge as well. There's also quite a few pre-built applications that you can leverage instead of creating from scratch. As a consulting firm, one thing we always like to do is encourage people not to try to reinvent the wheel. If someone's already built what you need, it's often much easier and cheaper to leverage that instead of building from scratch. So on that note, I want to thank everyone for their time. My contact info and Jaime's is here below. Feel free to ping us if you have any questions about Forge or want to speak further about this topic.
I want to say thank you all once again, but especially thank you, Mike, for all your awesome support.
Of course. Thanks, everyone. Have a great day.